In solving today's problem, the key point is to notice that the pebble is projected from a point 12 metres above the ground. It's not projected from ground level. So when we're drawing our diagram, it might be helpful to draw on our ground level and then the point of projection, which is 12 metres above, and then mark on the path that we're expecting the pebble to take as it goes up, and then it goes back down to the ground level again. Information from the question tells it's projected with 10 metres per second, and as it's travelling vertically, we know that we've got an acceleration due to gravity of 9.8. So, when we're looking at part A, we can consider what variables of suvat we have so far. And as we're looking for the speed at which it strikes the ground, we are going to look for the displacement from where it started to where it's going to finish, and I'm going to choose upwards to being my positive direction, so that would make my displacement a negative 12. Initial velocity is going upwards, that's 10. Final velocity is what we are trying to work out, and the acceleration is minus 9.8. So with those four variables, we're going to deal with v squared equals u squared plus 2as. Subbing in, v squared equals 10 squared plus 2 lots of minus 9.8 times minus 12, giving us a final velocity of 18.3 meters per second. As in part B, it's looking at a different position of the pebble. It's good practice to draw a second diagram. So we again have got our starting point, which is 12 meters above the ground. It's going to go up and back down again, and we're looking for the point at which it is 15 meters, and the important point here is above the ground. So the displacement we're looking for from the start is not 15, but instead is 3 meters. We've still got downwards acceleration due to gravity of 9.8, and we need to remember that as we're not dealing with the top point, then our velocity is not going to be 0 at the end. Okay, so suvat again. The displacement this time we're looking at to be positive 3, again taking up to be positive. My initial velocity is 10. Final velocity we're not going to know. Acceleration is minus 9.8, and t is what we're looking for. So with SU, A and t, we're going to be using S equals ut plus a half at squared. 3 equals 10t plus a half lots of minus 9.8 t squared. Rearranging, we've got 4.9 t squared minus 10t plus 3 equals 0. And therefore we've got a quadratic in t, so we're going to use our quadratic formula, which will give us t equals 10 plus or minus the square root of 10 squared minus 4 lots of 4.9 times 3, and that's all going to be over 2 lots of 9.8. It's a quadratic, so we're expecting two values of t, which are 1.675 and 0.365. You'll notice that I've given the first value to 4 significant figures because this is an in-between step in my calculation, so it's good practice to give it to an extra significant figure more than your answer. So the total time is the difference between those two, which is 1.31 seconds.